everyone, welcome to our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your software engineering class, and this is your class 2. As I told you, we had completed the one class where we had completed your unit 1, and in unit 1 which we had started with, and that is the name of the unit 1 is your introduction introduction to software engineering, and that we had covered up the 75% there. And now we'll surely start with another topic, which is your prototype model, as you can see here, and that will discussed here in the detail, and will surely complete in this class unit 1 for sure. And if it is not exceeded more than hours, so we'll just start discussing about the unit 2 as well. So don't worry about it. The question that has been asked is to discuss prototype model, and that is of has been asked of 1 times in 2.5 marks and 2 times in the 5 marks as well. Before starting with this, it's a huge request from my side to all the viewers. Please go through with the subscribe button, and please like, share and subscribe our channel, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. In the same case, if I'm talking about here, that is the discuss the prototype model here. In a prototype model, in prototyping model initially, in this the prototyping here, that in prototyping model initially the requirements gathering is done here, where developer and a customer define overall objectives and identify area needing more requirement gathering as well. Then a quick design is prepared, and this design represent what will be the visible to user in input and output format as well. Now we'll discuss about it, that from the quick design a prototype is prepared, and the consumers or that users they evaluate the prototype in order to refine the requirements. Iteratively, the prototype is need that tuned for the satisfying the customer's requirement. Thus, prototype is important to identify the software requirement as well. When working prototype is built, developer use existing program fragment or program generator to throw away the prototype and rebuild the system to high quality as well. So we'll go ahead with a further one that we'll have to discuss here, which is your that is the diagram of prototype. So this is we have. So here we go ahead, and that is your further that will gives you, and that will comes, that is your prototype model. So in terms of prototype model that we're discussing here, and in this if I'm talking about it, that for the prototype model that we have, this is the communication with customer, that will get turns to building of quick design, then it will goes to the construction of prototype, then it will go to the deployment, delivery and feedback. So this is how the prototype model works. First is communicate with the customers, building of quick design, then the constructions of prototype, and then it goes to the deployment, delivery and a feedback, and it all then comes to the communicate with customers as well. In the same case, we'll discuss the other question that we have to discuss here, which is the another question has been asked. Explain about prototyping model of software development. What are the advantages of it over waterfall model? So about the prototyping model which we had discussed here, but this is a structure as well. But other than that, this has been asked with 10 marks, so 5 marks is all about this, and the second is that the advantages of it over waterfall model. So advantages of it over waterfall model. In this, a general objectives of software is defined but not detailed that input, processing or an output requirement, then in such a case a prototyping model is useful. When the developer is unsure of the efficiency of an algorithm or the adaptability of an operating system, then prototype serves as a better choice. Now we will go ahead with, that is the other question, why are evolutionary models considered by many to be the best approach of to the software development in the modern context? This has been asked for 5 marks. We are in the same case for the evolutionary model that we'll talk about it. In terms of evolutionary model here, that evolutionary models are iterative, and on each iteration the software product is getting built and becoming more sophisticated. The developers gain the knowledge about the development of the product from earlier version, the refinement and the updation that can be made using the previous version, the risk analysis that can be done at each iteration, the developers that can maintain proper communication with the customers and feasible changes suggested by them that can implement it on each iteration as well. Now we'll go ahead with a further one that we'll discuss here, the iterative enhancement model. And the question has been asked here, which is that which type of application suit Rad model, and justify your answer. And in the same case, we'll talk about the Rad model here. In terms of Rad model here, that we have to talk about it, the Rad model is suitable for information system application, business applications, and the for system that can be modelized because of the following reasons. This model is similar to the waterfall model, but it uses a very short development cycle. It uses the component-based construction and emphasis that reuse and code generation as well. This model uses multiple terms on scalable projects. The Rad model is suitable for the projects where technical risks are not high. The Rad models requires heavy resource as well. Now we will discuss the moreover related to that, which is the comparisons among the various models. The first comparison that we deal with it, which is that is to differentiate between waterfall model and prototype model. Differentiate between waterfall model and prototype model. So differentiate between the waterfall model and that is your prototype model that we have to discuss here. This has been asked of 3 times in the examination paper of 5 marks. In terms of waterfall model here, waterfall model, when requirements of the projects are fully understood and if the requirements are gathered at the beginning of the project, then waterfall model is performed, and that is preferred as well. In prototype model, that when customer requirements are not clear and technical issues are unsolved, then in such a situation prototype model is preferred. The other difference is that in waterfall model the final product is available to the customers only at the end of the model. In the prototype model, the working prototype that can be built at every phase of development and that can be presented for the approval to the customer. Thus, at every stage of the development working model, prototype is refined. In this waterfall model, that this model is suitable for small systems, and for prototype model, this model is suitable for large systems. For the fourth difference, we have only developer participate. There is no user participation in all the phases. For the prototype, both the developer and the user participate for building the prototype here. The other, for the waterfall model, there is no use of reusable component, and for prototype, reusable component that can be used for building the next prototype as well. Now we will be going ahead with the other difference between that we have to discuss here, which is what are the software process models that we had discussed here, and distinguish iterative enhancement model and spiral model. So let's go ahead with that. The difference between spiral model, this has been asked of 2 times in the examination paper of 5 marks, and iterative enhancement model. So that we have to discuss here. In spiral model, the requirement analysis and gathering that can be done in iterations because requirements get changed quite often. In iterative enhancement model, the requirement analysis can be made in the later stages of the development cycle. In spiral model, the development team having less experience of working on the similar project is allowed in this process model. In iterative enhancement model, the development team having the adequate experience of working on the similar project is chosen to work on this type of a process model. In a spiral model, there is no user involvement in all the phase of development process, and here there is the user involvement in all the phases of the development process. In spiral model, due to the iterative nature of this model, risk identifications and rectification is done before they get problematic, and hence for handling real-time problems, the spiral model is chosen. In iterative enhancement model, when the requirements are reasonably well defined, the development efforts suggest a purely linear effort, and when limited set of software functionality is needed quickly, and then the incremental model is chosen here. So these were the differences between the spiral model and iterative enhancement model as well. Now we will go ahead further, and that we have to discuss another difference between waterfall model and spiral model. So difference between waterfall model and spiral model. In this, for the waterfall model, if I'm talking about here, waterfall model, it requires well understanding of requirements and familiar technologies. In spiral model, it is developed in iterations, hence the requirements can be identified at new iterations. In waterfall model, difficult to accommodate changes after the process has started. And in spiral model, the required changes can be made at every stage of new version. In waterfall model, that can accommodate iteration but indirectly. In spiral model, it is iterative model. In waterfall model, risk can be identified at the end which may cause failure to the project, and in the spiral model, risk can be identified and reduced before they get problematic as well. Now we'll discuss the another one here. So the other difference is that the customers that can see the working model of the project only at the end, and after the reviewing of the working model, if the customer get dissatisfied, then it cause a serious problem. And in this spiral model, the customer can see the working product at certain stages of iterations. Where the waterfall model, the customers prefer this model. Here, the developers prefer this model. In this model is good for small systems, and this model is good for large systems. It has sequential nature and it has evolutionary nature here. So this is the differences here. Now we will go ahead with other one, which is they can ask you about the short answer questions of 2 marks, which is the first question they can ask you is, what are 2 types of software product? Two types of software product. So what are 2 types of software product that we have to talk about it? So there are the 2 types of software product which we have as follows. The first we have is generic. In generic, these products are developed and to be solid to the range of the different customers as well. The second we have is your custom. In custom, these types of products are developed and sold to the specific group of customers and developed as per their requirements as well. Now we'll go ahead with further one, that what we have to discuss here, which is another question, and that is, what is meant by blocking states in linear sequential model? In linear sequential model. So blocking states in linear sequential model here, In this, the linear nature of the linear sequential model brings the situation, the project, that some project team, the members have to wait for other members of the team to complete the dependent task. The situation is called blocking state in linear sequential model. For example, after performing the requirement gathering and analysis step, the design process can be started. That hence the team that working on design stage has to wait for gathering of all the necessary requirement. And similarly, the programmers cannot start coding step unless and until the design of the project is completed. Now we'll talk about what are the advantages of prototyping model that we have to deal with it. Advantage of prototyping model. So advantages of prototyping model here that we have to discuss here in this, that is the working model of the system that can be quickly designed by constructions of prototype. This gives the idea of the final system in the user here. It's to be its user. The prototype is evaluated by the user and the requirements can be refined during the process of software development. This method encourages the active participations of developer and user. This type of a model is cost effective. This model helps to refine the potential risk associated with the delivery of the final system. The system development speed can be increased with this approach as well. That we have to talk about it. The another one we have. So here we go ahead. Write any two software engineering challenges. Two software engineering challenges that we have to talk about it. The key challenges faced by the software engineering are, the first we have is your delivery times challenges as well. So we'll talk about the delivery time challenges that we have to talk about it here, and that we have as follows. In terms of delivery time challenges that we have, that there is increasing pressure for the faster delivery of software, and when the complexity of the systems that we develop increases, this challenge becomes harder. We'll talk about the second type of software engineering challenges that we have to face is your heterogeneity challenge. In heterogeneity challenge here, sometimes systems are distributed and include a mix of hardware and software. This implies that software system must that cleanly integrate with other different software system built by different organization and team, which may be using different hardware and software platform. Now we will discuss about it, which is the another question that has been asked is to identify in which phase of the software life cycle the following document are delivered. That we have to talk about it. In this, that the document will be delivered in the phases that we'll discuss. The document we have is your architectural design, test plan, cost estimate, and the source code document. So that we will do it. Here we'll just make a sort of a table here. So here we have a sort of table. Here we'll write it down for the document. This is a phase. So on the same basis we'll talk about it. There are four that you will have your document. The first document is your architectural design. In this, the phase we have is your design. The second is your test plan. The phase we have testing. The third we have is your that is cost estimate. And the phase we have is your project management and planning. Fourth we have is your source code to document. So the phase we have is your coding. Okay, now we'll further move ahead with other question that what we have to discuss here in the same cases, and which we have the other question is what are the phases encompassed in the Rad model. So the phases encompassed in the Rad model that we have to talk about it. Phases encompassed in the Rad model. So here various phases encompassed in the Rad model here. The first we have business modeling. The second we have data modeling. The third we have process modeling. The fourth we have application generation. And the fifth we have testing and turnover. Now we'll talk about the other question that we have to discuss here, which is state the benefits of waterfall life cycle model for software development. For this, the first we have is the waterfall model is simple to implement. The second, for implementation of small systems, the waterfall model is used. These were the two benefits of waterfall life cycle model for the software development. The other question has been asked is that is to how does project risk factor affect the spiral model and software development. So the spiral model demands considerable risk assessment because a major that a risk is not uncovered and managed, and problem will occur in the project and then it will not be acceptable by the end user as well. We'll talk about the other question that has been asked as you define software. So in terms of defined software, the software is a collection of computer programs and a related document that are intended to provide the desired feature, functionalities and performance, and a software that can be of two categories as I told you about it, which is the first we have is your generic software. The second we have is your custom software. The next and the last question of the session that what we have to talk about it, what is software process? In terms of what is software process here, in this, that is the software process can be defined as the structural sets of activities that are required to develop the software system. The fundamental activities that are as follows. The first we have is your specification. The second we have is your design and implementation. The third we have is your validation. And the fourth we have is your evolution. So that what we have to cover up. So here we had end up with unit 1. We'll start with the next coming class, that is of unit 2 here, and that is the software requirement specification that we have to talk about it. So we'll go deal with that as well. So in these what we had to cover up in the software engineering. Other than that, we are dealing with the reasoning here, where we had completed the verbal reasoning, and we had started with the non-verbal reasoning, where we had completed the series topic which is of more than 1000 questions, and analogy which we had done more than 500 questions as well. And other than that, we'll start with the classification in the reasoning as well. And chemistry for class 12 for academic and competition we are dealing with. Software engineering we are dealing with. Other than that, we are dealing with the quantitative aptitude, where we had completed in arithmetical ability, we had completed the operations on numbers, LCM and SCF of numbers, and decimal fraction that we had started with, and we had completed that, and we had started with this fourth topic, which is simplification. With reference towards the software engineering, that is the unit 1 we had started with, which is introduction. That is into introduction to the software engineering, software components, software characteristics, software crisis, software engineering process, similarity and the differences as well. And from the conventional engineering process, software quality attributes, software development life cycle, SDLC model, waterfall model, prototype model, spiral model, evolutionary model, development model, iterative enhancement model as well. In unit 2, which is your software requirement specification, that is your SRS, the requirements engineering process and elicitations, analysis, documentations, reviews and management of their need, feasibility study, information modeling, data flow diagram, and entity relationship diagram, decision tables, SRS document, IEEE standards for SRS as well. Then we'll discuss about in unit 2 only, the second part of the software quality assurance, which is SQA, where we'll discuss about the verification and validation, SQA plans, software quality framework, ISO 9000 models as well. Other than that, that is SEI, SEMM model as well. And then in unit 3 we will discuss about software design, which is that is your basic concepts of software design, architectural design, low level design, modelizations, design, software charts, pseudocode, flow charts, coupling and cohesions, measures and design strategies, functional that oriented design, object oriented design, top down bottom up design, software measurements and metrics, various size oriented measures, and that is your Hillstead software science, functions point based measurement, and that is your cyclometric complexity measures and control flow graphs as well. Other than that, in unit 4 we will discuss about software testing, which is testing objectives, unit testing, integration testing, and that is acceptance testing, regression testing, testing for the functionality and the testing for the performance, top down bottom up testing strategies, test drivers and desktops, structural testing, white box testing, functional testing, black box testing, test data suite preparations, alpha and beta testing of products, static testing strategies, format technical review, peer reviews, walk thorough, code inspection, compliances with the design and coding standards as well. In unit 5 we have to cover up the software maintenance and software project management, where we have to discuss the software as an that is evolutionary entity, need for maintenance, category of maintenance, preferences as well, corrective and perfective maintenance, cost of maintenance, software re-engineering reviews, reverse engineering, software configuration management activities, change control process, software version control, and overview of case tool, estimations of various parameters such as cost, efforts, schedule duration, constructive cost model, that is COCOMO, resource allocation model, software risk analysis and management as well. So that all we have to discuss in the next coming classes, and here we'll end up with, and this is not more than hour or the hour classes, so it is a short class for you all, and you can just go through with that. So please go through with that, and please go through with the subscribe button as well. So it's a huge request from my side. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on a comment box. Thank you.